What's up, everybody? Mr. Kozad back again with another video lesson. Man, I hope that you are just in an awesome spot right now. Thanks for finding this video. I got to tell you, before we do anything else, if you've been with me before, you know what I'm going to say. Today is a great day to be alive, y'all. I'm so happy that you're here. I hope that this video is helpful for you. I hope that you learned something that you didn't learn before. And I hope you have some fun as we go through this. So today's topic is conic sections. And the specific conic section that we're looking at today are hyperbolas, okay? If you are my student and you've been tracking along with our textbook, this is 9.5 in our textbook. So for this lesson, all you really need is something to write with and something to write on. And let's go ahead and add one. Let's have a good attitude, and we are going to jump right in and have a great time together today with hyperbolas. Here we go. So the very first thing that we're going to do, and we're going to spend a little bit of time on this, we're going to actually unpack all the attributes of a hyperbola. We'll talk about what is it, what's the shape of the graph look like, what are all the attributes. You're going to find that a hyperbola is actually really, really similar to an ellipse. There's a lot of things that are similar from a hyperbola and an ellipse. In fact, you can think about this hyperbola as an ellipse. Think about an ellipse like this, and if I cut it on each end, I got a pair of scissors and cut it, and folded each side out, watch this, okay, I'm going to erase those two sides. So I cut that that ellipse in half at the vertices, and I opened them up. What I actually get is a hyperbola, okay? So let's go through some of these attributes together, and we will clear that page, and we will go, like I said, this part's going to go kind of slow because it's really important that you know these attributes, okay? First things first here is the center point, okay? The center is obviously right in the middle, okay? And the coordinates of that center are going to be HK. Now, if you look at each one of these branches, okay, this looks similar to maybe when we did rational functions, okay, similar style of graph to rational functions, okay, not exactly the same, but similar style. We have two branches here, and each branch has a vertex. Each branch has a vertex, so let's label those accordingly. There's a vertex on branch 1 and a vertex on branch 2, okay? Now, the line segment that connects the vertices, so the line segment that connects the vertices is called the transverse axis. It's called the transverse axis, okay? Now, the next thing that I'm going to do before I move on, so in the same way as the ellipse worked, the distance between the center and a vertex is still going to be A units. So that's nice. We can remember that the distance between the center and the vertex will still, in a hyperbola as well, be A units. And I'll teach you in a minute how to find A for hyperbolas. Okay? Next, now the next attribute doesn't really actually show up on the graph, but let's talk about these seemingly random points out here on the left and the right of the center. Okay? These points are called Co Vertices, okay? And I'm going to put those in quotations because they're not really vertices because they're not really on the function, okay? But they're going to operate like co-vertices, and those points are actually going to be helpful for us. We'll see that in just a minute, okay? Now, the distance from the center to a co-vertex is B units, just like it was for the ellipse, okay? All right, lastly, these other random points that are kind of on the interior, the inside of these branches, okay? Those are the focus points, okay? So there are two focus points. And if you watch the 9.4 lesson on ellipses, we say plural of focus is foci. That's how I say it. Some people say foci. Foci feels a little safer to me, feels a little better rolling off the tongue than foci, okay? Now, again, similar to the ellipse, the distance from this is getting kind of crowded here, but we got it, okay? The distance from the center to I want it to be purple. The distance between the center and a focus point will be C units as well. The distance will be C units, okay? Now, lastly, the last line that we have here, or what do we call these dashed lines? Okay, well, these dashed lines are asymptotes. There's asymptotes here. There are actually 2 asymptotes for every hyperbola. And again, I will teach you how to find those. Okay. Now, the last thing that I'd like for you to do here, okay, and this is going to come in handy here in a little bit, is I'd like for you, please, to draw a imaginary box that's going to exist on the kind of the interior of this hyperbola. And here's how you're going to draw it. Okay. You're going to draw that box starting at a co-vertex, and you're going to go up, and then you're going to go over, pass through the vertex, go down through the other co-vertex, go over through the other vertex, and then right back where you started. Okay? Now what actually is going to happen here is that rectangular box is going to be really important when we find the slopes of these asymptotes. Okay? So I'll come back to this in just a minute. I'm going to show you this picture again, and it's going to be really helpful for us if you have this rectangular box drawn. Okay? Notice how it passes through the vertices, and it also passes through the pseudo co-vertices, okay, called pseudo co-vertices, not really co-vertices because they aren't actual points on the curve, okay? All right, now, next slide, we're going to go through the 2 different varieties of hyperbolas. We can have a vertical hyperbola, which is what we're looking at right now, or we can have a horizontal hyperbola, okay? So let's talk about those 2 scenarios, okay? Best plan for you would be to pause the video right here and write this chart down, this blank chart, write it down in your notes, and then hit play again when you're done so that we can go through this quickly. But stop right now and actually recreate this chart that you see in your notes. Okay, welcome back. Hopefully you actually have a beautiful chart here ready to take some awesome notes. Okay, so the first thing that I'd like you to look at is I'd like you to just take a minute and study the similarities and the differences in the equations. Okay, notice how they are very, very similar. Okay, the only thing that's actually different here is the numerator in each equation. Okay, notice how a squared is always first. Okay, notice how we, instead of plus, we have a subtraction sign here. Okay, so ellipses were addition, but hyperbolas are subtraction. Okay, and like I just said, notice that a squared always comes first, and that is going to be an attribute of these equations. Okay, so down here way at the bottom, okay, down here way at the bottom, the first note that I want you to write yourself is that a squared is always first. Now this is a big time difference than the ellipse, because for the ellipse, a squared didn't always have to be first, but a squared always had to be the greatest. Okay, so here's where it's different. Pay attention, listen, open your ears, pay attention to this. Okay, for a hyperbola, a squared always comes first. For an ellipse, 9-4, what we did last lesson, for an ellipse, a squared is always the denominator that is the largest, okay? So for the hyperbola today, 9-5, a squared always comes first no matter what, okay? A squared always comes first no matter what, okay? So you're going to have some scenarios where a squared is smaller than b squared, and that is totally fine, okay? Okay. Now, let's go through this first column here. Okay, so here's what you're going to look at. You're going to see the subtraction sign in your equation, and you're going to know that it's a hyperbola. You're going to know this first term, or this first denominator, is a squared. And then you're going to look and see which variable is in the numerator. So in this case, we have x. When x is in the numerator of the first term, this is going to be a horizontal hyperbola. Now, the branches of the horizontal hyperbola look like this. They open to the right and the left. Now, what's nice about this is that sort of looks like the sides of an H, okay? Sort of looks like the sides of an H. So that might be an easy way for you to remember that it's horizontal, okay? Looks like an H. Now, the center. The center here, just like it always has been in Chapter 9 and much of Algebra 2, will be at HK. Now for the vertices, you have to remember which letter you use to find the vertices. Do you use A, do you use B, or do you use C? Okay, the correct answer, which at least one person probably said out loud, and listen, it's okay. If I ask you a question and you want to say the answer out loud, go for it. It's not weird. I promise. I'm doing this lesson and I'm talking out loud to no one. Okay? It's okay. Just say it out loud. Nobody's even going to really know. Okay? I promise. Okay? Unless you're out in public, maybe say it softly. Don't say it really loud. I'm getting distracted. Let's keep going. Okay. Vertices. We always use A to find the location of our vertices, whether it's a hyperbola or an ellipse. It doesn't matter. Okay. So if this is a horizontal orientation, meaning the branches are to the left and the right of the center, I'm going to add and subtract A to the H value. So the vertices will be at H plus or minus A, comma, K. Now for the co-vertices, you're going to go the opposite direction that you went for the vertices, and you're still going to use B, okay? So we've got H, comma, K plus or minus B. Now for the foci, remember that the foci will always be on the same line as the vertices, so it's always going to look very similar. So we're going to have H plus or minus C, comma, K. Okay, the length of the transverse axis. Remember, the transverse axis is the one that connects the vertices. So that's going to be 2 times A. And oh no, I did not label the conjugate axis on the diagram. What are we going to do? Okay, the conjugate axis, I'll tell you now, the conjugate axis is the line segment that connects co-vertex to co-vertex. So the length of the conjugate axis is going to be 2B. Okay, now you can actually cross out the axis of symmetry here. We're not going to talk about axis of symmetry in this part of chapter 9, so you can cross that out. Don't worry about it. Now we get to the fun part, the asymptotes. Okay, now here's the deal for the asymptotes. Okay, go back and look at your picture that you labeled. The asymptotes here are linear. Okay, and we are going to write the equations of these asymptotes in point slope form. Okay, now where do these asymptotes intersect? Okay, you're right, they intersect at the center. So what are the coordinates of the center? Well, the coordinates of the center are at HK. All right, so here's what I know. Let's go back and let's build this. We know that we're going to have y minus a y value, and that's going to equal a slope times x minus the, whoa, sorry about that. Hold on, let me get back here. Okay, x minus h, y minus k, because we're going to use the center as our shared point. Okay, so now all that we're missing here is we're missing the slope. Now go back and look at your picture. Remember that slope, and let me zoom in on this box. Okay, remember that slope is rise over run. Okay, it's a rise over run. So here's the question that you ask yourself, okay, when you're identifying the slope of the asymptote. Do you rise A or do you rise B? And this is going to depend on the type of hyperbola that you have. Okay, so if you go and you look here, okay, would you rise, look at this little miniature hyperbola I drew. Do you rise A or do you rise B? That's the question. Well, with an ellipse or a hyperbola that's oriented horizontally, you rise B and you run A. So our slope of those asymptotes are going to be plus or minus B over A. Rise B, run A. Okay? Now, plus or minus means that one of them is going to be positive, one of them is going to be negative, but it's the same number. It's the same numerical value. Okay? All right, let's breeze through our next column where we have the opposite kind of hyperbola. Okay, so again, just to recap, you see the subtraction sign, okay? You know that a squared comes first. So then you look at the numerator and you see a y. When you see a y in the numerator, okay, of the first term, that is called a vertical hyperbola. And a vertical hyperbola is like one that we just labeled. Okay, it's set up just like the one we just labeled. The center is still going to be at HK. The vertices, I'm going to go up and down A units. So keep H the same and add and subtract A to your Y value of the center. The co-vertices are going to go left and right, B units. The foci are going to be on the same line as the vertices, so we're going to go up and down C. So keep H, K plus or minus C. The transverse axis is still 2A. The conjugate axis is still 2B. And now let's talk about the asymptotes. Okay? The asymptotes here are still going to be y minus k equals plus or minus some slope times x minus h. So now let's go back and let's look at our picture. Okay? Remember, rise over run is how we find slope. So if this is the center, do you rise A or do you rise B? Well, I'm going up to the vertex, which is A, so I rise A and I run B. So the slope here is going to be A over B. Okay? Now there's one final thing that I need to tell you before we move on, and that's the relationship between A squared, B squared, and C squared. This is another major difference than the ellipse. Okay? For hyperbolas, C squared equals A squared plus B squared. C squared equals A squared plus B squared. Now, for the ellipse, remember that it was C squared equals A squared minus B squared. But again, this is one of the biggest differences between the two conic sections. To find C squared, you take the sum of A squared and B squared. Okay? So that is a quick overview of all of the nitty-gritty details of a hyperbola. So the next thing we're going to do is we're going to do 4 example problems together, okay? So if you need to take a break, pause it now, get a drink of water, maybe get a snack or something, and come back and get with me when you're ready to do 4 example problems with me, okay? I don't need a drink. I don't need a snack. I'm ready to go, so let's roll, okay? Here we go. Example number 1. Sketch a graph and identify all the critical attributes. Okay, so I scan this equation here that they give me, okay? First thing I see is that both variables are squared, okay? Next thing I see is that I have a subtraction sign in between, and this equals 1. Those are all important things to pay attention to. So I know that because of the subtraction sign and because they're both squared, I know that this is going to be a hyperbola. Okay, so let's go through and let's identify a squared. Now, remember that a squared always comes first. So a squared here is going to be the first denominator no matter what it is. So a squared equals 4. B squared will always be the one that comes next, so that's 16. To find C squared, you add A squared and B squared, so that gives me 20. So now let's take it one step further and let's identify our A, B, and C values. So A equals 2, B equals 4, C equals 2 root 5. Okay? So the next thing that I'm going to look at is what variable is in the numerator. The x comes first. So that tells me that this is going to be a horizontal hyperbola. So it's going to look something like this, the h, horizontal, the h. Okay? So then the next thing that I'm going to do is find the center. Okay? So let's start by identifying all of our key attributes. We got the hard work done. Okay? The center is HK, so 3, -2. The vertices, remember you use the A value, and you're going to go to the left and the right A units. Okay, so that's changing the X value here. So if I go to the left 2 units, I end at 1, -2. And the other vertex would be at 5, -2 as I add 2 to the X value. Okay? Next, let's talk about the co-vertices. The co-vertices, remember the co-vertices aren't points on the curve, but they're actually up 4 and down 4 from the center. Okay? So if I go up 4, I'm at 3, 2. If I go down 4, I'm at 3, -6. Okay? The foci, okay, are always on the same line as the vertex, okay, or the vertices.
So we're going to take 2 root 5 and we're going to add that to 3. Now because 2 root 5 is irrational, you can just leave it as 3 plus or minus 2 root 5, okay? Now the last attribute that we need here is the equation of the asymptotes, okay? Now, if you look at the graph, here's a trick, okay? If you draw in that rectangular box, okay, draw in that rectangular box that passes through the A value, or I'm sorry, the vertices and the co-vertices, and then if you draw the diagonals of that box, you will have drawn the asymptotes of this function, okay? So we know that it's going to be y plus 2 equals plus or minus some slope times x minus 3. So remember, we use the center point. So now we just have to find the slope, and drawing this picture is what's going to help us with that. Remember, the slope is rise over run. So on this particular graph, do you rise A or do you rise B? We rise B and we run A. So my slope here is going to be plus or minus B over A. And Cozad, you're silly. You actually know what B over A is. So that's 4 over 2, which we could simplify to simply 2, a slope of 2, and a slope of negative 2. Okay? So there you go. That is a very super simple, straightforward example that's really kind of fun on how to find the attributes of a hyperbola. There's number 1. Now let's jump into number 2. Okay? Sketch a graph and identify all the critical attributes. Okay, easy. Exact same directions as the last time. But, oh no, this format is not good. No bueno, okay? So we get the opportunity to do some completing the square, okay? I hope you're excited about that. I know that I am. We get to complete the square not to once, but twice. So pay attention. Here's how I'm going to rewrite this. So let's rewrite it as 9y squared minus 54y minus 4x squared plus 32x. And let's go ahead and add the 19 to the other side. Okay, let's add the 19 to the other side. All right, so here we go. Let's have some fun. So first, let's take the y's and let's factor out a 9. So we have 9 times y squared minus 54 divided by 9 is 6. Okay, so we have minus 6y. Now let's go ahead and complete the square. So half of 6 is 3. 3 squared is 9. So we're going to add 9, close that parenthesis. Now to balance this out, we need to subtract 9 times 9. Because remember, this 9 that I wrote here, this plus 9, is being multiplied by the 9 right here. So to balance this equation out, if I add 81, I have to also subtract 81 to keep it balanced. Now be careful with the x's here, okay? What you're going to actually factor out first is you're going to factor out a negative 4, which makes that x squared, and watch this, makes the 32x minus 8x. Makes it minus 8x, okay? So then we hasas this. Half 8 is 4. 4 squared is 16. So we add that. And then to balance this out, we're going to subtract negative 4 times 16. And again, that still equals 19. Okay? So we've created some perfect square trinomials. So let's do some factoring. So we have 9 times y minus 3, the quantity squared. That is minus 81. And then we have minus 4 times x minus 4, the quantity squared. That is plus 64 equals 19. So move all the constants to the other side. We get 9 times y minus 3 squared minus 4 times x minus 4 squared equals 36. Equals 36. Okay? So divide everything by 36. Divide everything by 36. And we get y minus 3, the quantity squared, over 4, minus x minus 4 squared over 9 equals 1. Whew, so fun. Okay, so now we get to identify our a squared, our b squared, and our c squared. Okay, a squared always comes first, so it's 4. B squared always comes second. C squared is the sum of a squared and b squared. So take it one step further. We get a equals 2. We get b equals 3. And we get c is the square root of 13. Okay? So now let's go through and let's write out our attributes. Well, actually, let's draw a real quick sketch of this. Okay? So look in the y is the first numerator. So that is going to be a vertical hyperbola. It's going to look something like this. Okay? All right, so let's roll. We've got the center at 4, 3 is the center. And be careful in that center. Remember that h is always with x and k is always with y. Just because the order here is flipped does not mean that the center is 3, 4. Make sure you pay close attention to that. It's 4, 3. Okay. Vertices, I'm going to go up and down 2 units. So that's going to put me at 6, 3. And that's going to put me at 2, 3. Okay. No, it's not. I went left and right. Sorry, I knew that didn't feel right. I went left and right. My badness. Okay, so up and down. So we go 4, 5, and 4, 1 are the vertices. Okay. The Co Vertices are located, now those are the ones that go left and right by 3 units. So that's going to be 1, 3, and 7, 3. My foci are going to be up and down root 13 units. So that's going to be 4, 3 plus or minus the square root of 13. And lastly, let's do the asymptotes. Okay, let's do the equations of the asymptotes. So it's going to end up being y minus 3 equals plus or minus rise over run. So look at your graph. Do you rise A or do you rise B? We rise A. So it's going to be plus or minus A over B, which we can actually plug in the real numbers. Plus or minus A over B is plus or minus 2/3 times x minus 4. Okay? So again, hardest part here, in my opinion, is the completing the square to get you to your equation. Once you get there and once you get comfortable with the attributes, you're gonna breeze right through that. Okay? So 2 more together. Let's do 2 more. Okay, example 3. It says write the equation of a hyperbola that has vertices at 6, -2, and -2, -2, and foci at 10, -2, and -6, -2. Okay, so we've got a lot of info here. So let's go ahead and start building a picture of what's given to us. Okay. All right, so vertices at -2, -2, and 6, -2. Okay, so let's label these. So that's 6, -2. That's -2, -2. Those are the vertices. So maybe put a little v next to those. I don't know. Foci at 10, -2, which is out here. Okay, at 10, -2. That's a foci. Okay, so right away that tells me that these branches are going to look something like this and something like this. Okay, my other focus is out here on the left. All right. So let's see what we can figure out. So we know the center is going to be directly in the middle of those 2 vertices. So the first thing that I would do is figure out how far apart are your vertices. Okay, you go from -2 to 6. That's a total of 8 units. So that total distance is 8, which means the distance from each center to each vertex is 4 units. So that tells me that A equals 4. Okay. I don't know and don't have any information right away to find B, so that's the one that's missing. But I can find C. C is the distance, okay, from the center to a focus point, okay? So now let's actually find the location of the center. So the center is going to be at 2, -2. It's halfway between -2, -2, and 6, -2, okay? So then count how far apart is the center and the focus. Well, it's 8 units. So that tells me that C is 8. Okay? All right, now we use our relationship c squared equals a squared plus b squared. So plug and chug, we get 64 equals 16 plus b squared. So we get b squared equals 64 minus 16, which is 48. Okay? Now, if you're asked to write the equation, which we are, you don't even have to figure out what the actual b value is because you want b squared when you build the equation. Okay? So right now, here's what I know. I know that my first numerator is going to be a squared, which in this case is 16. I know my second denominator is going to be b squared, which is 48. I know it's going to equal 1, and I know it's going to be subtraction. Okay? So now here's what we've got to do. We've got to figure out which variable goes in our numerator, x minus h or y minus k for the first one. So here's where you got to remember the orientations. Okay, this hyperbola is a horizontal hyperbola, which means the x value has to come first. So it's going to be x minus h, which in this case is 2 squared, times y minus k squared. So here you are. X minus 2 squared over 16 minus y plus 2 squared over 48 equals 1 is the equation of that hyperbola. Okay? Look, we've got one more. Let's try it together. Okay? If you're feeling yourself and feeling really good, go ahead and pause it now. Try this one on your own. See if you can get it. But if you just want to keep going with me, man, that's awesome. We're going to keep rolling. Okay? So it says write the equation of a hyperbola centered at 3, -1. Ooh, yes. Okay, they give me the center. -3, -1. With a vertical transverse axis. Ooh, that's fun. That is 8√2 units. Ooh, I love when the units aren't nice, clean, easy whole numbers. Okay, so transverse axis being vertical means that I'm going to go up and I'm going to go down a units to get to those branches. So I'm going to have a hyperbola that looks something like this. Okay? All right. So because I know that total length is 8√2, that tells me that the distance from the center to one vertex is half of 8√2, which would be simply 4√2. 4√2 plus 4√2 gives me a total length of 8√2. Okay? Okay, next piece of information tells me the conjugate axis is 6 units in length, okay? So that means I go left and right. If I count those units, I get a total of 6 units, okay? Which means half of 6 obviously is 3. So here's what we know. We know that A is 4√2. We know that B is 3. So I know that my first numerator is always going to be a squared. So when I square 4√2, I get 16 times 2, which gives me 32. So a squared on this problem is going to be 32. I know my second denominator is going to be b squared, which is just 9. I know it's going to equal 1. So now all we have to do is figure out which variable goes in the first numerator. Well, look at the hyperbola that we drew a sketch of. This is a vertical hyperbola, which means y is going to come first. So we end up getting y plus 1, the quantity squared, and the second denominator is y plus 3, the quantity squared. That one was pretty straightforward, pretty easy. Okay? That's it, guys. That's all you need to know to be successful with conic sections and hyperbolas. I know it's a lot of information, and thank you so much. The real ones stuck around with me. Y'all know who you are. Those of you that stick around at the end, man, you're the realist, and I appreciate you. I see you, and I love you, okay? You guys are great. Have a good rest of your day or evening whenever you're watching this, and let me know if you need help with anything at all. Y'all are awesome. Check out